All right, Ninja Warriors, welcome to yet another power-packed session. And you all know that in today's session, we are going to cover all the PYQs of continuity and differentiability from January attempt, not for April attempt. I guess I forgot to update the thumbnail. Thumbnail says April attempt, but I'll correct it. But this session is all about January attempt. In continuity and differentiability, there were 10 questions were asked from this chapter. So you can just understand the weightage of continuity and differentiability together. Together, you will expect one question in your upcoming paper. Short one question from continuity and differentiability will be there. Highest probability of getting one question. Okay, before I start any further, can you please guys confirm me that I am audible and visible? Okay, I can see. Good evening Harshita. Good evening Rajkumari. How are you all? And also do like the session right away and share this session with your fellow JEE aspirants. All right, okay, so like we will do these 10 questions approximately within 45 minutes. That's the sole agenda, because I believe you must be thinking, ma'am, continuity and differentiability weightage is very less. No, I feel that continuity and differentiability, this chapter is an opportunity, because the questions are not that difficult. Sometimes the questions are very easy, like within 5, 10, 15 seconds you can do some questions. Okay, some of the questions. Some questions might take less than a minute, but yeah, overall basic, the questions are easy. Sometimes they get one question, hardly one question you will see tough in overall like January or April attempt. Okay, all right, good evening. Hi Harish, how are you? Harish and Maheshwari, good evening. All right, okay, shall we start? Shall we increase the brightness a little bit? Is it any better? The brightness, more brightness, better? Let me check. The output is better, kya? I am absolutely fine, Rajkumari. I guess, yeah, the output is relatively better. So let us start with the very first question. The very first question is from continuity and differentiability together, which says that the function is continuous everywhere in R, and the number of points where f is non-differentiable. Okay, so what they are saying is, if f is continuous everywhere and m represent number of points where f is not differentiable, then m plus a plus b equals what? Okay, all right, so first of all, let us talk about m, the differentiability later on. Let us talk about continuity. Okay, so if I talk about this piecewise function, only I can see that the function is breaking at 2 points, right? At x equals to 0 and at x equals to 1. So we need to make this function continuous at x equals to 1. The function is continuous at x equals to 1. That means f of 1 should be equals to f of 1 plus, should be equals to f of 1 minus. That's it. F of 1. Who can tell me f of 1? Ma'am, f of 1 will be equality is right here, f of 1, right? So it is 1 square plus c times 1 plus 2. So f of 1 is 1 square plus c times 1 plus 2. Now f of 1 plus, that means I am looking for x greater than 1. So it is 2 into 1 plus 1, right? So this is going to be 3. This is 3 plus c. This will give me c is equals to 0. C is 0. C is gone in this question. Okay, so this for x lying between 0 and 1, your function just became x square plus 2. Now continuity check done at x equals to 1. We will do continuity check at x equals to 0 as well. So f of 0 is equals to f of 0 plus is equals to f of 0 minus. Okay, so f of 0 equality is again here. So if I put 0 over here, 0 square plus 2. So this is 0 square plus 2. F of 0 plus, that means x greater than 0. Again, I will land into the same thing. I don't want same thing. F of 0 plus. Now f of 0 minus, that means x less than 0. X less than 0 is this. Now let us look at this. Okay, the moment I look at this now, a minus b cos 2x x square upon x square, this reminds me of my favorite limit. My favorite limit. Anybody who has studied continuity from me in road series, he or she will know that ma'am's favorite limit is limit x tend to 0, 1 minus cos x upon x square is equals to half. So basically 1 minus cos 0 upon same 0 whole square is half. Now here similar thing is getting created as just that a minus b. So a and b both should be equal or 1. Let us just do some guesswork. Let us write a and b both 1. So it is going to be 1 minus cos 2x upon x square, right? So I need 1 minus cos 2x upon 2x whole square. So basically I will need 4. 4 here, 4 here. So that this limit will become half. 4 into half is 2 only. So that means our guesswork worked this time. Our limit is coming out as 2. So for x less than 0, my value is coming out as 2. For a equals to b equals to 1. Right? So your C is 0, A and B both are 1, and I'm now looking for M. M is number of points where F is non-differentiable. Okay, so for that I will need one extra slide. I need to copy my Fx. My Fx now is 1 minus cos 2x upon x square. Let us go back. X square plus 2 and 2x plus 1. This will be x is less than 0. X is belonging to 0 close to 1 close, and this is x greater than 1. This is your f of x. Now what are you looking for? You want to check the differentiability of this function. Obviously the two suspicious point, two doubtful points will be what? Two doubtful points will be x equals to 0 and x equals to 1. Okay, so two doubtful points, x equals to 0, x equals to 1. So x equals to 1, let us just understand what is happening. So f dash x, I will do f dash x. So f dash x, if I differentiate, I will get 2. If I differentiate this, I will get 2x. Okay, and this is going to be x greater than 1. This is going to be x belongs to 0 to 1. For all of those who have watched the lecture of differentiability of mine from the road series, we will understand that ma'am, what is ma'am doing? For differentiability, there is a clear-cut shortcut. One way is obviously first principle of differentiability. Second way is just differentiate, and this differentiating this will not help. So this I am keeping it empty only. So x equals to 1 pe, you put 1 over here, so you will get 2 ones are 2. You will put 1 over here, you will get 2. So basically LHD you will get from here. LHD is 2 into 1, and RHD at x equals to 1 will be what? 2, directly 2. So basically they are equal. At x equals to 1, LHD and RHD are becoming equal. That means x equals to 1 pe function is differentiable clearly. Okay, now the whole sole point is, what about ma'am x equals to 0? We need to check the differentiability at x equals to 0. Okay, so basically the basic funda, see, x equals to 0 pe, why I am not doing the same thing? Because I need to differentiate this. Now this differentiation of this will not work for me. Who will apply that quotient rule? So what I'll be doing is, I'll be just doing, for a function to be differentiable at x equals to 0, LHD should be equals to RHD. Left hand derivative should be equals to right hand derivative. So limit h tend to 0. Left hand derivative f of 0 minus h minus f of 0 upon minus h should be equals to limit h tend to 0. F of 0 plus h minus f of 0 upon plus h. Okay, f of 0 minus h. So what is f of 0? Chalo, let's go back. F of 0, what is f of 0? So f of 0 clearly is 2, right? F of 0 is 2. Okay, so f of 0 will be replaced by 2. Here also it is 2. F of 0 minus h. What is f of 0 minus h? Tell me. So f of 0 minus h. That means we are looking for 0 negative, less than 0. So f of 0 minus h will be this. Just x will be replaced by minus h. So 1 minus cos 2 minus h upon minus h whole square. So this is f of 0 minus h. F of 0 upon minus h. This is limit h tend to 0. And f of 0 plus h. So this is the right hand derivative at x equals to 0. That we can do it by shortcut. Understand? At x equals to 0 plus right hand derivative will be given by this greater than 0. So greater than 0. So 2x, 2 into 0. Right hand derivative is clearly 0. We don't need to do this. Okay. This is fine. Now what about this? Let us just do it. 1 minus cos 2h minus 2h square upon h cube. It's a negative sign. Limit h tend to 0. Now expansion I will apply. This is LHD. I am applying expansion in that. Okay. So 1 minus h square by 2 factorial plus h power 4 by 4 factorial and so on. This is 2h square. This is 2h power 4 and so on. Minus 2h square upon minus h cube. So 1 cancel. This is 2h square with a positive sign. This is getting cancelled out with this. So clearly h power 4 upon h cube will give us h. H is 0. So the left hand derivative is giving 0. Why 0 equals to 0? What does that mean? What does that mean? That means that LHD RHD is equal. It is differentiable at x equals to 0 and 1 both. So the final answer is the number of points of differentiability will be 0. So finally the answer will be option D. 2 will be the correct one. Okay. All right. Clear. Chalo. Let's now talk about the next question in our plate, which is this. So the question is all about, again, yes, Likhit. The question is all about, again, continuity and differentiability. Continuity and differentiability, right? So fx is this, right? Now, I don't know if you have noticed that f of x is actually mod of 2 mod x square plus 5 mod x minus 3 mod. This is fx. So basically, I have done a little change over here. X square can be written down as mod x. Why am I doing that? Because if I assume that my gx is 2x square plus 5x minus 3, then your f of x is nothing but mod of g of mod of x. Correct or not? So what I'll be doing is, I'll be plotting gx, then I'll be plotting mod of gx, then I'll be plotting mod of g of mod of x, mod close. 3-step process. Then by looking at the graph, I'll be able to tell whether my function is continuous or differentiable. Although, again, students who have watched my lecture nicely, continuity, differentiability, row series, they will understand that I have already told that if a quadratic is given, right, and if you apply modulus in that quadratic, be it that modulus is on the function or the x, the function will remain continuous. So basically a continuous function is there, then mod of g of mod of x will also remain continuous. So what I'm trying to say is the function fx is continuous at all the points. So m denotes point of discontinuity. So clearly m will be 0 directly, I can say. Point of differentiability we need to check. Okay. Both I will tell you with the help of the graph. 2x square plus 5x minus 3. So gx. 2x square plus 5x minus 3. This is your graph. Let us do here. G of x, 2x square plus 5x minus 3. So minus 3 is a root, I guess. So x plus 3 and 2x minus 1. Is it? Yes. 2x square plus 3 to the 6. Correct. This is the factorization. So that means this graph will be having upward facing parabola having two roots. One will be minus 3. Another will be half. Okay. And this, most probably this will be your graph of gx. This is your gx. This is gx. Now you have to plot the graph of g of x with a mod. Okay. So that will give you mod 2x square plus 5x minus 3. How do you plot a graph of mod x? You know that. You just have to take this lower portion. You just have to take the lower portion. The mirror image of this lower portion above. Okay. Flying pen problem. This has become a flying pen problem. Okay. So this part will be like this. So 3 minus 3 will be here. Half will be here. And this is how it is. This is how it is. This is how it is. Okay. All right. This is your graph of mod of g of x. Now next step. Now the graph will be mod of g of mod x. How do you frame the graph? This is mod 2x square plus 5 mod x minus 3 mod close. Okay. So now in the same graph, I'll try to manipulate this. So basically, whenever you have to plot the graph of g of mod x, you have to completely remove the left hand side of the graph. Just remove it. So try removing this. Remove. And now what you need to do is, you need to just take mirror image of this graph about y-axis. Take mirror image of this graph about y-axis. So that is how it will look like. So this is the graph of the final, this thing. Okay. And now clearly that this graph is continuous because there are no breakpoints. So continuity points will be 0. What about the differentiability points? So 3 points of differentiability because the sharp corner I can see 3. So clearly the correct answer will be option D. Okay. All right. Clear. Chalo. Let us now move on to the next problem. Okay. So this is our next problem again. See, piecewise functions in JEE Main from continuity and differentiability are very common. Okay. All right. Now, y-axis, ma'am. Vijay, I guess that you have not watched my complete row series. You guys are taking row series very lightly. I have done a session on transformation of graphs where I have clearly mentioned that is how the approach is, why the approach is. Just go and watch that session. The session is not more than like 2 hours. Within 2 hours, you can, if you want to watch it in 2x speed, like within 1 hour, you can finish the session. You will understand this question better. Okay. All right. Chalo. Now let us talk about this question, which is this. Now what they are saying is this question has the function is continuous at x equals to 3. Then the number of elements in S is what? Okay. All right. Let us tackle it. Let us tackle this question as well. So 3 pe the function is continuous. That means f of 0 will be equals to f of 0 minus will be equals to f of 0 plus. Okay, so now f of 0, sorry, not 0, what am I doing? F of 0, no, f of 3, right? F of 3 is equals to f of 3 plus is equals to f of 3 minus, correct? F of 3 is B. F of 3 plus greater than 3, where is greater than 3? Here. If I just rewrite for you guys, because it might not be visible for you, sign of x minus 3, correct? Whole upon x minus greatest integer function of x. So f of 3 plus, the moment you put 3 plus, so see, for x equals to 3 plus, your GIF of 3 plus will become 3 only. So this thing is 3 only directly. This thing is 3 only for 3 plus. Okay. So this is 3 plus ke liye, this is 3 only. So sine x minus 3 upon 3. So limit x tend to 3 plus sine 2 raised to power sine x minus 3 upon x minus 3. Tell me. Sine 0 by 0 is 1. So b will be equals to 2 raised to power 1. And f of 3 minus. Now for x less than 3 is this. Now understand. This is what? A upon b. This thing clearly is 7x minus 12 minus x square. Okay. So this is actually, if you take minus sign common, na, this is x minus 3 and x plus 4. Correct? Sorry, x minus 4. Yeah. Okay, if you factorize them. What about this? Mod of x minus 3, x minus 4. Okay, now what are you doing? X less than 3, right? If you will put x less than 3, understand, modulus is involved. If you put x less than 3, wavy curve method also suggests put any number which is less than 3. Put x equals to 2. If you put x equals to 2 inside this modulus, this is also negative, this is also negative. So overall you are getting positive. That means that the modulus will get open with a positive sign. So minus a upon b, this is positive only. X minus 3, x minus 4, modulus got opened. And this is x minus 3, x minus 4. So again, these two are getting cancelled out. Minus a by b is that thing what you're going to get. So b is coming out as 2, correct? Now minus a by b is 2. So this implies minus a by 2 is equals to 2. A is coming out as minus 4. So now what we are getting is a is minus 4. B is 2. That's it. We are getting only single set of A and B. What they are saying in the question is S denotes the set of all ordered pairs A comma B. S denotes set of all ordered pairs A comma B. So only ordered pair. I am getting single ordered pair, right? Option D. Okay. Give me a big thumbs up if you have understood this. Mini, when will we going to complete, ma'am? I guess you guys are asking, what are you asking? This session? This session will not take much time, I guess. Within half an hour, we'll be able to finish. Okay. All right. Now, consider the function f, okay? So this is the function which is defined. This is actually a good question, tricky question, difficult question. I mean, this does not belong to JEE Main easy category. No, it does not belong to JEE Main moderate category. I guess this is a very good question, topper level question, okay? So let us understand this question nicely. Consider this function. This is the function, okay? And the function gx defined by this. Then gx is continuous but not differentiable at x equals to 1. Gx is, so they are always talking about gx, so we need to focus on gx. Gx from 1 to 2 it is sorted, but from 0 to 1 gx is depending on f of t. Basically it is depending upon f of x. So these are the typical standard problems. Okay, standard problem. There is a standard approach to do that. Whenever you see that gx is minimum of f of t, always focus on plotting the curve f of x. So we will always behind our f of x. F of x is x upon 2 plus 2 by x. Now if you want to plot this curve, obviously you want to know where the function is increasing, where the function is decreasing, where are the critical points, maximum, minimum, application of derivatives a little bit. F dash x. So again this is 1 by 2 minus 2 by x square. Okay, 1 by 2 minus 2 by x square. So now I need to talk about only in 0 to 2. Can you see the domain of this function f is 0 to 2, right? This is the domain. So if you put 0 over here, okay, so what will you get? Half minus infinity. Half minus infinity, the function will be less than 0, right? Basically what I'm trying to say is, if you try to plot the graph now, f of x 0 and 2, this is your fx, okay? So the moment you see that x equals to 0, you are going to get positive infinity, right? So this is how your graph will look like. The moment you write 1, so this is going to be something around here. The moment you write 2, so this is approximately 2, right? So this is how your curve is going to become. This is how your curve f of x, right? F of x. And this is a decreasing function. Why? Because see, you put 2 over here. So this is going to be half minus 1 by 2. Half minus half. So 0. Almost 0 you're getting, right? The moment you put 2 over here. 2. So 2 ka square. Half minus half 0. But before 2, you can't put 2, right? You put 1. Tell me half minus 2. That is negative. What I'm trying to say is this is negative for all values of x belongs to 0 to 2. So the fx is a decreasing function. Fx is a decreasing function. The moment you put 1, half plus 2 will be 5 by 2. And this value you are going to get 2 over here. This is infinity, right? So have you understood that how to plot the graph of fx? Now just tell me. Fx is a decreasing function. Okay? Now they are saying that g of x is minimum of f of t, where t is lying between 0 to x and x lying between 0 to 1. Let me just give you perfect explanation. You understand what I'm trying to say. Suppose you want to know what is g of, let's say, 0.9. Okay. Ma'am, what is g of 0.9? G of half. Okay. G of 1 by 3. All these values you want to know, right? So, ma'am, G of 0.9. So, you want to understand that x over here is 0.9. X is 0.9. So, your t will lie between what? 0 to 0.9. So, minimum of f of t means minimum of all the values of f of 0 to 0.9. What will be the most minimum between 0 to 0.9? What is the most minimum? F of 0 is minimum, f of 1 is minimum, f of 0.1 is minimum. So this is 0. So between this interval, which is the most minimum value of f of x? So this is the minimum value, right? This is the minimum value. That means for a decreasing function, this exactly will be the minimum value. So g of 0.9 will be f of 0.9. Now, g of half, that means you're looking for g of x equals to half. This time x equals to half. One more example, okay? So, x equals to half. That means your t belongs to 0 to half. So, they want you to write the minimum value of function where the input of the function varies from 0 to a half. So what they are saying is, consider the interval 0 to half, and in this interval, whatever is the minimum value, just write. In this interval, just tell me this is the minimum value. F of half only is the minimum value. What does that mean? That this g of x is actually f of x directly. G of x is f of x in the interval 0 to 1 because the function is decreasing. Okay, so g of x. Now, if I try to plot the graph of g of x here, this is your g of x. So, between 0 to 1 at exactly 1, you have to plot fx. Gx and fx both are equal. So, this is the graph of gx. This is 5 by 2. After 1, what is happening? Ma'am, after 1, it is a straight line, 3 by 2 plus x. So, if you put 1 over here, so 5 by 2 it is coming. If you put 2 over here, 2 2s are 4, 7 by 2 it is coming. So this is like this, straight line, like this, okay? So 1 to 2, between 1 to 2. Can you see that there is a sharp corner which is involving at x equals to 1? So function gx is non-differentiable at x equals to 1 clearly. So non-differentiable at x equals to 1 but continuous at everywhere. Option 1 is correct. Yes. Okay. So I believe that this is a like typical, this is not a JEE main question, frankly speaking. This is a JEE advanced level question. Sometimes it happens in JEE main, they give such question. And this concept, they have not asked such question in JEE main in past few years, right? This is a very old question we used to solve in our institutes when I used to teach in Kota. Okay. So this is that question. Rare question, rarely asked. So do not get carried away. If you're not able to understand, na, then don't just feel ki, okay, like for the very first time, I'm not sure why I'm not understanding, etc., etc. It's fine. Okay. Now, next question, f of x is given as this. They are saying the function is differentiable on R. Okay. So again, piecewise is there. Before differentiability comes continuity. So x equals to 2 pi, we need to apply the condition of continuity. F of 2 equals to f of 2 plus. F of 2 is 1 upon mod 2, which is 1 by 2. F of 2 plus x, okay, so sorry, 2 minus, yeah. F of 2 minus x less than 2. So that will be a2 square plus 2b. So 4a plus 2b equals to half. This is the first equation. Okay. And now what about differentiability? So this is continuity. Differentiability, for differentiability at x equals to 2, we need to apply that shortcut method I told you, differentiate. F dash x minus 1 upon x square for x greater than 2. I am only talking about positive, forget about modulus. Let's not talk about the negative things, okay? And this is 2ax, that's it, for x less than 2 but greater than 0 for positives. Now, differentiability at x equals to 2. So, LHD, tell me, x less than 2, LHD will be 2a and 2, that is 4a. And RHD you will get for x greater than 2 minus 1 by 2 square minus 1 by 4. These two should be equals. 4a is equals to minus 1 by 4, a is minus 1 by 16. So if a is coming out as minus 1 by 16, you can put your a over here. 1 by 2 minus 4 by 16 minus 1 by 4 plus 2b. So 1 by 4 plus 1 by 2. 3 by 4, 3 by 8. B is 3 by 8. Is it correct? B is 3 by 8. So, yeah. 48. A plus B minus 1 by 16 plus 3 by 8. Multiply. So, this is minus 3 plus 8 6 are 48, 6 3 are 18. 15 will be the correct answer. Yes. Okay, clear? Yes, give me a big thumbs up if you have understood this. Ma'am, 3 by 4. You guys are saying 3 by 4. 3 by 4. No. So 3 by 4, then 2 is also here, no? 2 will go in the denominator. It will become 8. 15 is absolutely correct, my dear students. Okay. All right, another question on your screen with same setup. I guess this you can do homework. A and B are real constants such that function f is defined by this. Differentiable on R. Yes. First of all, you make condition of continuity at x equals to 1. Then second, differentiability at x equals to 1. Then you get the value of A and B. Once you are having the values of A and B, now that you have your function, x less than 1, x greater than 1. Now what you need to minus 2 to 2. So minus 2 to 1, you have to like integrate this. Okay, plus 1 to 2, you have to integrate bx plus 2. Okay, and b and a you will get from this thing. So the integration will not be a difficult task because this is a general polynomial integration, right? So not a very difficult integration. Yes, so this I am leaving up to you, DIY homework question. And now let us talk about this question. Okay, all right, this is a good question, I would say. Gx be a linear function. Do you know what is a linear function? Do you know what is a linear function? The moment I see this, so I can assume Gx equals to Ax plus B, correct? Fx is equal to Gx when x is less than or equals to 0, and for x greater than 0, this is your f of x, right? Now they are saying the function is continuous at x equals to 0. So first of all, we'll apply this condition. F of 0 is equals to f of 0 plus is equals to f of 0 minus. F of 0 is g of 0 and g of 0 is b. F of 0 plus will be limit of this function 1 plus x, 2 plus x, power 1 by x, where x tend to 0 plus. Now I don't know how many of you have watched my roar series. How many? Yes, Mahalakshmi, Muthulakshmi. I am not able to read your correct name, but you guys, you are Muthulakshmi. Yes, Muthulakshmi, you are saying you are my favorite teacher. Just tell me, prove that I taught you limits in roar series. Have you watched it? First of all, give me reply, yes or no. I taught limits chapter, complete chapter in roar series. Just tell me. Have you watched it? In that series, I always mentioned that whenever there is a limit question, always find form of that limit first. Yes or no? I told you. Now see that how much effective is that. Now the moment you put 0, you will realize that 1 plus 0 and 2 plus 0. So this is becoming 1 by 2 half. Half raised to power 1 by 0. Half raised to power infinity. Who will tell me? Half raised to power infinity is not even an indeterminate form. 0.5 raised to power infinity is 0. Just do it on calculator. 0.5 multiply 0.5 1,000 times. You will get a number which is very, very smaller number. Eventually, if you apply infinity power, it will become 0. So this is 0. Now, if you just like try to apply the formula of tools, techniques of limits, it will become very, very wasted. Yes, Harish, it is not 1 power infinity. That is the catch over here. That is why if you mug up things, you will stuck in these type of questions. But if you understand the logic behind it, I told you in road series, the big session I took, limits chapter, always calculate form of that limit. Just go and watch every question. You must be thinking, ma'am, you're like talking very waste. Don't talk too much. But in every question, I am saying it to you. Always calculate form of that limit, because in such situation, you will avoid making mistakes. Okay. All right. So B is coming out as 0. That means your Gx is just Ax. Finally, your Gx is, this is your new Gx. B is gone. Okay, so this condition is done. Now, f dash 1 is f of minus 1. F of minus 1, can anybody tell me what is f of minus 1? See, f dash 1 is equals to f of minus 1. F of minus 1, so f of minus 1, that means x is less than 0. So it will become g of minus 1. F of minus 1 is equals to g of minus 1, because your fx is gx, right? So g of minus 1 will become minus a f dash 1. So your a will become negative f dash 1. Correct? This is your a. So now f dash 1. Understand, f1, they are not talking about f of 1. They are talking about f dash 1. So f dash x you have to figure out. But which one? This or this? You are looking for f dash 1. X greater than 0, so you have to differentiate this. Let me just go back and differentiate. So if your f of x is 1 plus x upon 2 plus x raised to power 1 by x, then how do you differentiate? By logarithmic differentiation. Logarithmic differentiation, take log and then differentiate. So log of y is equals to 1 by x log of 1 plus x upon 2 plus x. Correct? Now differentiate. 1 by y dy by dx equals to 1 by x constant product rule. Derivative of this, derivative of log of this is reciprocal of this 2 plus x upon 1 plus x. And then derivative of this thing inside function. So this will be quotient rule, 2 plus x whole square, 2 plus x, derivative of numerator will be 1 minus. This time 1 plus x remains constant, derivative of this is 1. Right? So 1 by x constant, this is how you differentiated log of 1 plus x by 2 by x minus, sorry, plus product rule. This time log of 1 plus x upon 2 plus x is kept constant, derivative of 1 by x is minus 1 by x square. Let's not forget this y. Y I am cancelling over here and y I'll be multiplying over here. Okay. Now this is your dy by dx, that means f dash x is this. Now you have to figure out f dash 1. Just start putting x equals to 1 in this whole thing. So 1 upon 1, 2 plus 1, 1 plus 1, 3 by 2. This is x cancel, 2 minus 1, 1 upon 3 square, 1 by 9, plus log of, this is x equals to 1, 2 by 3, and this is minus 1 by x square, so minus 1. Let's not forget that we have a y in multiplication. What is y? This is y. So we need to put 1 over here. Basically, f of 1 will be equals to y of 1. This y is f of 1. So it is going to become 1 plus 1, 2 by 3. This is your 2 by 3. So you need to multiply this whole thing by 2 by 3. Okay, so f dash 1 finally will become what? This is 3. So 1 by 6 minus ln 2 by 3, and you are having one more 2 by 3. If you multiply this inside, what will it become? F dash 1 will become 1 by 9 minus 2 by 3 log of 3. This is your f dash 1. 1 by 9 minus 2 by 3 log of 2 by 3. Correct? Now put the value. So a is equals to minus f dash 1. So a will be equals to minus of, so this is going to become what? 1 by 9, correct? Minus 2 by 3 log of 2 by 3. Correct? A will be equals to what? 2 by 3 log of 2 by 3 minus 1 by 9. This is your final answer of A. A. This is A. Okay? A. So now A is here. What is Gx? So Gx is A. So G of 3. So G of 3 will be what? 3 times A. So 3 multiply this will be your answer. So if you multiply this with 3, so 2 log 2 by 3 will be your answer. 2 log 2 by 3. Hold on. 2 log 2 by 3. Yes. 2 G of 3 is what? 2 log 2 by 3, correct? Minus, so you are multiplying 3, minus 1 by 3. So minus 1 by 3. So now 2 is not here. You have to match. So this is log of 4 by 3 minus 1 by 3. Correct? And again it is not matching. So you have to multiply by log E. So this will become what? Finally log 4 by 3 and upon log 4 by 3. Log of, okay, which answer is correct? Sorry, this is 9. Log 4 by 9 e raised to power 1 by 3. Yes. Log 4 by 9 e raised to power 1 by 3, which is matching with option 4. Yes. This is same as this option. Option D is absolutely correct. Okay. So sometimes it happens you're very close to the answer. See what happened? You're very close to the answer, but you're still feeling that, okay, there is so much mismatch with the answer. But if you see that 4, this will go over here. 2 will go over here. So 4 by 9, log 4 by 9. 1 by 3, you can multiply log E. This 1 by 3 will go in the power. So now this will become what? Log of 4 by 9 minus log of e की power 1 by 3. Now log m minus log n will be log m by n. 4 by 9 e की power 1 by 3. Can you see clearly? This is the correct answer. D option. Yes? Okay. Yes, Shreyas. Limits I have already done. Shreyas, what are you doing? Please don't do that. Limits I have already done. Right? Okay. All right. Now this question is there in front of you. This is your E again. This question says that consider the function defined by fx equals to e power minus log x. F of x equals to e की power minus log of x mod. Okay. And again, continuity and differentiability is something they are discussing in this question. So what we will do is we will define this function f of x will be equal to, for c, minus log x. Okay. So first case, when log x is positive. Tell me when log x is positive. That means log x is greater than log 1. So that means x is greater than 1. So the moment you write x greater than 1, that means log x is positive. This will become e raised to power minus of log x. Okay. And for x less than 1, e raised to power minus. So basically your log, if your x is less than 1, then what will happen? Your log x will be less than log of 1. Okay. Log x less than log of 1. So log x will be less than 0. When your log x will become less than 0, log x becoming negative, modulus will get open with a negative sign. So e raised to power minus of minus log x. So basically, if you understand, e raised to power ln x is x and e raised to power minus ln x will become 1 upon e power ln x, and this is 1 by x. Okay. So now your updated fx, finally you can write your fx. For x greater than 1, let me write it over here. You will have x 1 by x and x for x less than 1. You can apply equality anywhere because the moment you put 1, it will also become 1. It will also become 1. No issues. So that means clearly the function is continuous at x equals to 1, right? Function is continuous at x equal to, that means m, number of points where function is discontinuous will be 0 because we just checked. Okay. If at all I plot the graph, for x less than 1, we are having fx equals to x. For x greater than 1, we are having function 1 by x. 1 by x looks like this. This is the graph of fx. Correct? And now can you see the graph is continuous but not differentiable? So this will be 1. 0 plus 1 will be the correct answer. So option C is absolutely right. M plus 1 is this. Okay. So I guess we are done with the last question of this session. And yes, I guess MVSAT. About MVSAT, if I want to tell you, link is already given in the description box. You can give the MVSAT examination both online and offline. Depends. I suggest, recommend that if at all it is possible, if the center is in your city, then go and give the MVSAT examination in your center. Just meet another bunch of your fellow JEE aspirants, connect with them and talk to them so that you understand what is happening around the world. Okay, just come out of your comfort zone. You will get that vibe of actually JEE Main paper, because in JEE Main also you will see a lot of JEE Main aspirants. So it will be a similar experience for MVSAT. If at all it is not possible, go to the online and before 27th October, just apply. Link is given in the description box. And yes, if you want to connect with me on my personal Telegram channel, you can just join my Telegram channel, subscribe to it, t.me/Namrata Jaisinghani. I know it is big, but this is the spelling. You have to check it out. And then you can just subscribe, you can comment, you can ping me, we can have a healthy discussion. Any PDFs, any material you want, I'll be providing there only. This is me, Namrata, on this note, signing off. I'll see you all in next video.